Have you ever stood outside on a perfectly clear, moonless night, looking up at the vast, glittering expanse of the dark sky, and wondered why everything in the universe feels so completely, peacefully still, even though we are hurtling through an endless void at unimaginably violent speeds? We feel the solid, ancient ground securely beneath our feet, and we feel the gentle, cooling evening breeze softly brushing against our skin. We experience the quiet calm of the nocturnal world, a profound, enveloping stillness that naturally invites deep, meditative reflection. Yet, the rigorous scientific reality of our cosmic situation is entirely different, presenting a beautiful, mind-bending paradox that gently but firmly challenges our very basic perception of everyday reality. The earth beneath us is continuously spinning on its tilted axis, carrying us through the dark. It is perpetually orbiting our golden sun and our sun, along with its entire complex family of orbiting planets, circling moons, tumbling asteroids, and streaking comets, is sweeping through the silent void of the Milky Way galaxy at a tremendous speed of roughly 500,000 miles per hour, even moving at that incomprehensible, staggering velocity, a speed so tremendous that human imagination begins to falter and gently surrender. It still takes our solar system about 250 million years to complete just a single grand lap around the distant, glowing galactic center. Astronomers sometimes refer to this unimaginably vast period of time as a cosmic year, or a galactic year. To put this immense time scale into a gentle perspective that our minds can quietly absorb without feeling academically intimidated, consider this profound truth. In the entire sweeping era that giant dinosaurs roamed the earth, dominating the ancient land and skies, our solar system did not even complete one full, single orbit around the heart of our galaxy. The very last time our bright sun was in roughly this exact position in the Milky Way's swirling disk, the most complex, advanced life on our pale blue planet consisted merely of simple marine organisms, drifting peacefully in primordial ancient oceans. That is exactly how vast and deep even our own familiar galaxy truly is. Our home, the magnificent Milky Way, is what brilliant scientists classify as a barred spiral galaxy. It possesses beautiful, gracefully curving arms made of ancient stars, cold gas, and drifting dust, all slowly swirling around a densely packed central bulge where an enormous, silent black hole patiently sits in the dark. From one extreme edge of this cosmic pinwheel to the other, our galaxy measures roughly 100,000 light-years across. That means if you could somehow magically travel at the absolute speed of light, which is the ultimate, unbreakable speed limit of our universe, and the fastest that anything can possibly move, it would still take you 100,000 years of continuous, silent journeying just to cross from one side of our galactic home to the other. 100,000 years is a span of time significantly longer than modern humans have even existed upon the earth. It is an ancient duration, longer than the time since our distant ancestors first learned to press their hands against cold cave walls and paint their dreams. It is far longer than the rise, the flourishing, and the eventual quiet fall of every single human civilization combined. And yet, humbling as it is, that is merely the width of our own little, quiet corner of the infinite cosmos. The space between the billions of stars in the Milky Way is almost unimaginably, profoundly empty, a dark silence that invites a deep sense of inner peace. Our very nearest stellar neighbor, a small, quiet red dwarf star known as Proxima Centauri, is located about 4.24 light-years away from our sun. That distance is so breathtakingly, vastly great that if you were to gently shrink our massive sun down to the minuscule size of a single grain of sand, Proxima Centauri would be just another tiny grain of sand sitting quietly about 4 miles away in the dark. The vast, sweeping space in between these two solitary grains of sand would be essentially an absolute void, containing only the faintest, most delicate whiff of cosmic gas and dust, alongside the occasional silent particle of radiation passing through the endless night. This profound emptiness is very hard for us to comfortably wrap our minds around, creating a productive tension between what is known and the vastness of the unknown. We live our daily lives on a crowded, bustling planet, surrounded by billions of other human beings, constantly sharing our limited space with countless other living things. We are so deeply used to density, to things being intimately close together, to the physical world feeling full and tangible. But the moment you mentally step outside the familiar, comforting boundaries of our solar system, pure emptiness becomes the absolute, governing rule of the cosmos. When you look up at the night sky from a truly dark, quiet location, that hazy, glowing band of soft light stretching majestically overhead is actually the combined, ancient glow of billions upon billions of distant stars residing within our own galaxy. Ancient people, looking up at that exact same sky with the same natural curiosity that we feel today, thought it looked remarkably like spilled milk flowing across the dark heavens, which is precisely where the familiar name Milky Way comes from. For the vast majority of human history, we humbly assumed that this beautiful band of light was absolutely everything. We thought our spinning galaxy was the entire, complete universe. Different, beautiful cultures crafted different, poetic explanations for that glowing band. The ancient Greeks shared captivating stories of milk spilled from the goddess Hera's breast. The Romans looked up and called it the Milky Road, a silver pathway through the night. In India, it was viewed with deep reverence as the sacred path that souls gently take on their quiet journey to the afterlife. Aboriginal Australians, possessing a deep connection to the cosmos, saw it as a grand, flowing river in the sky. People throughout all of history have looked up at that very same band of light and gently wondered what it might truly be, united by a shared, implicit community of cosmic explorers. When the very first primitive telescopes were finally turned toward the Milky Way in the 17th century, dedicated observers began to quietly realize that the milky, ethereal glow miraculously resolved into countless individual stars, objects far too faint and far too numerous to ever see with the naked eye alone, but suddenly visible through the clarifying power of glass lenses. This was our very first gentle hint that our galaxy was far larger and contained far more hidden wonders than anyone had previously dared to imagine. But it was not until the 1920s that a patient astronomer named Edwin Hubble scientifically proved that those fuzzy, mysterious smudges of light people had been seeing were actually entire galaxies themselves, each one an island universe containing billions of its own unique stars, and each one sitting impossibly, staggeringly far away from us. That single, quiet discovery fundamentally changed absolutely everything we thought we knew about our modest place in the cosmos. Hubble made this world-altering discovery at the Mount Wilson Observatory in California, utilizing what was then the absolute largest telescope in the world, a magnificent reflector with a mirror exactly 100 inches across. He was observing a specific class of stars called Cepheid variables in what was then referred to as the Andromeda Nebula. These fascinating stars pulse in their brightness with a very regular, predictable period, beating like gentle cosmic hearts in the dark. By carefully measuring their apparent brightness and their steady pulsation rate, Hubble could accurately calculate exactly how far away they were. The resulting data was profoundly shocking. The Andromeda Nebula was not just a cloud of gas within our own galaxy. It was roughly 1 million light-years away, sitting far beyond the outermost edges of the Milky Way. We now understand that Hubble's original distance estimate was slightly off by about a factor of 2, and the Andromeda Galaxy is actually about 2 million light-years away. But his fundamental, awe-inspiring conclusion was entirely correct. The universe was vastly, incredibly larger than anyone had imagined, filled with countless galaxies. Today, we estimate that there are around 2 trillion galaxies floating in the observable universe. That is a 2 followed by 12 zeros, a number so immense that it transforms our human ignorance into a deep, peaceful motivation to simply learn and marvel. But what makes this cosmic journey truly fascinating is that not all galaxies are created equal. While some are tiny dwarf galaxies and others are beautiful spirals like our own, sitting out there in the extreme, quiet depths of the cosmos are the true monsters of the universe, galaxies so enormously vast that they challenge the very limits of our human imagination and gently invite us to completely expand our perspective of what is physically possible in this beautiful, ancient night. Have you ever looked at the gentle, fading light of a quiet sunset and wondered how nature creates such infinite variety from a few simple rules? The vast, silent universe operates on this very same principle of magnificent diversity, inviting us on a quiet journey of continuous discovery where every new observation deepens the beautiful mystery of existence. When we gaze deeply into the ancient cosmos with our most powerful instruments, we find that the 2 trillion galaxies scattered across the observable universe are not just identical copies of one another, but rather a tapestry of unique, magnificent islands of light. They come in a breathtaking array of beautiful shapes and quiet sizes, each telling its own unique, unfolding story of cosmic evolution over billions of years of deep time. The most common type in our nearby universe are the spiral galaxies, much like our very own beloved Milky Way, boasting their distinctive, sweeping pinwheel arms and flat, rotating disks that slowly turn in the silence of space. These elegant galaxies are typically vibrant sites of active star formation, where brilliant new stars are being born right now in the cool, gas-rich spiral arms, surrounded by a gentle cocoon of primordial dust. The beautiful, balanced structure we see in a spiral galaxy is carefully maintained by a delicate, cosmic dance between the rotational motion of the spinning disk and the relentless, binding gravitational pull of all the matter held safely within it. But there are other, more mysterious shapes drifting in the dark, profound silence of the vast cosmos. Elliptical galaxies represent another major structural type in the infinite night. Unlike the gracefully sweeping spirals, these gentle giants have no particular organized structure, appearing instead as smooth, featureless clouds of ancient starlight that glow softly in the deep universe. They quietly range from nearly spherical orbs to highly elongated oval shapes, and they are populated mainly by older red stars that have been burning peacefully for billions of years. Star formation in these peaceful elliptical galaxies has largely ceased, as they have gently exhausted almost all of their available gas supply over the long, quiet eons. The absolute largest galaxies in the entire universe are almost exclusively elliptical, formed slowly and deliberately through the quiet, inevitable merger of multiple smaller galaxies over billions of years of cosmic history. Additionally, there are the irregular galaxies, which possess no defined, symmetrical shape at all, often appearing as chaotic but beautiful, gentle smudges of glowing light in the cosmic dark. These are frequently the direct result of intense gravitational interactions with nearby, larger galaxies, which have powerfully pulled and distorted their original structures over immense periods of time. The Magellanic Clouds, which are faintly, beautifully visible from the southern hemisphere of our Earth, serve as perfect, quiet examples of irregular galaxies that are currently being stretched and affected by the Milky Way's massive gravitational pull. As we continue this quiet journey of discovery, finding deep peace through the expansion of our perspective, we realize that these islands of stars are not just scattered randomly through the vast empty space. They are deeply organized into much larger, more complex structures that span across the infinite dark, connected by invisible threads of gravity. Galaxy groups generally contain anywhere from a handful to a few dozen galaxies floating together in the silence. Our own Milky Way belongs to a quiet, familiar neighborhood called the Local Group, which contains about 80 known galaxies, beautifully including Andromeda and several dozen smaller, gentle dwarf galaxies. Galaxy clusters are larger still, containing hundreds to thousands of massive galaxies, all bound together by the invisible, inescapable grip of gravity in a delicate cosmic embrace. And the largest, most incomprehensible structures of all are superclusters, which are vast, sprawling assemblages of galaxy clusters stretching across hundreds of millions of light-years of space, forming the very architecture of the universe itself. The specific galaxy I want to gently introduce to you today on this journey is one of those true monsters of the ancient universe, a cosmic structure that inspires an overwhelming sense of wonder and deep humility. It goes by the somewhat mundane, boring scientific name of IC 1101, which simply comes from its entry number in a scientific catalog of celestial objects carefully created over a century ago. But do not let this dull, technical name gently fool you, because there is absolutely nothing boring about this quiet, cosmic giant. IC 1101 sits majestically at the very center of a massive cluster of galaxies called Abell 2029, safely located in the direction of the constellation Virgo, as seen from our quiet Earth. When dedicated astronomers point their powerful telescopes toward this specific region of the night sky, they see a massive, ancient collection of galaxies, all eternally bound together by gravity, gently dancing around a single, common center in the cosmic silence. And right in the quiet heart of that massive cluster, dominating absolutely everything around it, like a cosmic emperor resting peacefully on a throne, sits IC 1101. This single monumental galaxy is scientifically estimated to be somewhere around 4 to 6 million light-years across. I want you to simply pause and let that staggering number sink into your mind for a gentle moment, allowing the profound sense of awe and quiet wonder to wash over you, easing any earthly tensions you might be holding. Our Milky Way galaxy, which already seemed impossibly, infinitely large, is only about 100,000 light-years wide. IC 1101 is roughly 40 to 60 times larger than our entire sweeping galaxy. If you took IC 1101 and gently placed it exactly where our Milky Way currently sits in the dark void, it would not just completely engulf our galaxy. It would swallow our entire cosmic neighborhood in a profound, absolute silence. The massive Andromeda Galaxy, which is about 2.5 million light-years away from us across the empty space, would suddenly find itself entirely inside IC 1101's unimaginably massive body. The Triangulum Galaxy, another close neighbor of ours, would also be instantly, quietly consumed. All of the dozens of smaller dwarf galaxies that quietly orbit around us, ancient places like the Large Magellanic Cloud and the Small Magellanic Cloud, would simply become tiny, insignificant components of this single giant's vast, sweeping structure, disappearing into the infinite deep. But mere physical size is just the very beginning of the profound mystery of what makes IC 1101 so incredibly breathtaking to behold. This gentle, ancient giant is scientifically estimated to contain around 100 trillion stars. 100 trillion. Our Milky Way has maybe 400 billion stars at its absolute most. That astonishing reality means that IC 1101 has roughly 250 times more stars than our entire home galaxy combined. If you started counting the stars in IC 1101, counting exactly 1 star per second without ever stopping for a single breath, it would take you over 3 million years just to count up to 100 trillion. And that impossible calculation is assuming you never slept, you never ate, and you never took a quiet break of any kind. The sheer scale of this object generates a respectful sense of wonder and humility before the vast unknown, gently transforming our natural lack of comprehension into a deep, peaceful desire to learn more about the universe we inhabit. The deeply human story of exactly how we discovered this magnificent cosmic giant begins back in the year 1790, when a German-born British astronomer named William Herschel was systematically scanning the dark, quiet night sky with his handmade telescope. Herschel was widely considered to be one of the absolute greatest, most dedicated astronomers of his historical era. He had already discovered the distant planet Uranus several years earlier, and he peacefully spent much of his long, quiet life cataloging thousands of celestial objects that absolutely no one had ever scientifically documented before. On June 19th of that specific year, Herschel pointed his telescope toward a quiet region of sky in the constellation Virgo and noticed a faint, fuzzy blob of soft light. He carefully, methodically recorded its precise position in the heavens and gently moved on to the next mysterious object in the darkness. At the time of this quiet observation, Herschel had absolutely no way of knowing what he was actually looking at. The advanced technology simply did not exist to measure how incredibly far away this object truly was. The fundamental scientific understanding did not yet exist to recognize that it was an entire, independent galaxy, completely separate from our own. Herschel simply logged it in his quiet notes as another mysterious nebula, one of many glowing, cloud-like objects randomly scattered across the ancient heavens, waiting silently to be understood. For well over a century, that faint, silent smudge of ancient light remained a profound mystery, quietly waiting in the dark to reveal its true nature to a curious, searching humanity. It was eventually given the scientific designation IC 1101 when it was formally included in a comprehensive catalog called the Index Catalog, which was an important expansion of an earlier, more primitive list of celestial objects. Dedicated astronomers studied it when they could, seeking a peaceful connection with the deeper mysteries of the vast cosmos. But without the precise modern tools to understand its true, staggering nature, it remained just another quiet entry in a long, endless list of cosmic curiosities. Everything changed in the 20th century when brilliant scientists developed much better telescopes and entirely new mathematical techniques for measuring immense cosmic distances. They finally discovered that IC 1101 was not just a small cloud of gas floating within our own galaxy. It was an entirely separate, ancient galaxy, mind-bogglingly far away in the deep silence of space. The ancient light that we see from IC 1101 today actually left that distant galaxy over 1 billion years ago. It has been quietly traveling through the absolute void of deep space for more than 1 billion years, just to gently reach the lenses of our modern telescopes. When that light first began its impossibly long journey toward us, biological life on our Earth was still mostly composed of simple, single-celled organisms resting in quiet, primordial oceans. Complex animals had not yet even evolved. The mighty dinosaurs would not appear on the land for another several 100 million years. Every single major, impactful event in human history, from the rise of the very first civilizations to the brilliant invention of the telescope itself, happened while that ancient, tired light was still silently crossing the deep, infinite emptiness between galaxies. It is a gentle reminder that the universe operates on timescales that dwarf individual lives, inviting us to simply breathe, let go of our daily anxieties, and embrace the profound peace of being a small but aware part of this magnificent, ongoing cosmic journey. Have you ever sat quietly by a slowly flowing river, watching the small, gentle streams merge together into a vast, powerful current, and wondered how the universe builds its most monumental structures out in the infinite dark? As dedicated astronomers continued to deeply study the ancient light of IC 1101, they began to carefully uncover the profound, awe-inspiring reasons why this particular galaxy became so incredibly, unbelievably massive. This majestic giant did not simply grow to its enormous, mind-bending size through normal, isolated processes acting alone in the void. It became an absolute titan of the deep cosmos through a continuous, slowly unfolding act of cosmic interaction that has been quietly happening in the dark for billions of years. IC 1101 is what brilliant scientists refer to as a cannibal galaxy. It has been systematically, inevitably eating other smaller galaxies. To truly understand the gentle but irresistible power of galactic cannibalism, you need to deeply think about how the fundamental force of gravity works on the absolute largest scales of the universe. Galaxies do not exist in complete, lonely isolation in the deep night. They are naturally grouped together in massive clusters, held safely and eternally together by their immense mutual gravitational attraction. Within these colossal clusters, galaxies slowly, gracefully move around each other, sometimes passing quite close by, and sometimes colliding directly in a slow-motion dance that unfolds over millions of years. When two peaceful galaxies get close to each other in the silent depths of space, their mutual gravity immediately begins to gently distort their beautiful shapes. Ancient stars get slowly pulled out of their normal, predictable orbits, tracing new, elegant paths through the darkness. Vast, floating clouds of cold gas and cosmic dust get compressed and stretched like ethereal ribbons of light. If the two interacting galaxies are roughly similar in their overall size, they might eventually merge together over hundreds of millions of years, slowly and beautifully forming a single, much larger galaxy. But if one galaxy is significantly, vastly bigger than the other, something entirely different and profoundly humbling happens in the dark. The much larger galaxy simply absorbs the smaller one, gently stripping away its billions of stars and its drifting gas seamlessly adding absolutely all of that raw material to its own massive, growing body. This is exactly what has been happening to IC 1101 for billions of quiet years. As the absolute largest and most massively dominant galaxy in its entire cluster, IC 1101 sits powerfully at the gravitational center of absolutely everything around it. Smaller, wandering galaxies that venture just a little too close get inevitably trapped by its enormous, inescapable gravity. They begin to spiral inward, getting slowly, silently torn apart and completely consumed for millions of years of cosmic time. Each of these cosmic meals makes IC 1101 a little bit bigger, a little bit more incredibly massive, and a little bit more physically dominant in its ancient neighborhood. Dedicated scientists carefully estimate that IC 1101 has undergone at least 76 major mergers over its incredibly long, sweeping history. 76 distinct times, another substantial, independent galaxy fell inevitably into the gravitational embrace of this cosmic giant and was entirely absorbed into its massive, glowing body. And those are merely the major, significant mergers that left a clear scientific trace. Countless other smaller dwarf galaxies have also been quietly consumed over the eons, galaxies so very small that they barely even registered as a meal for this enormous, silent predator of the dark. The physical evidence for this relentless, cannibalistic history is deeply written in the very structure of IC 1101 itself, serving as a magnificent, glowing monument to the immense forces of nature. When you look at a beautiful, younger galaxy like our familiar Milky Way, you see a stunning, highly organized spiral pattern. Those graceful spiral arms are active regions where brilliant new stars are constantly forming, where vast dark clouds of primordial gas are gently collapsing under their own gravity to creatively build new stellar nurseries. Spiral galaxies possess lots of cool gas and dust, the vital raw materials desperately needed for new star formation, and they proudly boast a distinct, beautiful, rotating disk shape. But IC 1101 looks absolutely nothing like this familiar, comforting structure. It is exactly what astronomers scientifically call an elliptical galaxy, which simply means it has a very smooth, featureless, oval-shaped appearance, with absolutely no spiral arms to be found anywhere within its vast expanse. These giant elliptical galaxies exclusively form when earlier, beautiful spiral galaxies violently merge together in the cosmic night. The intense, chaotic gravitational interactions during a major merger destroy the delicate spiral structure, mixing the billions of stars together into a random, spherical, or elongated oval distribution. The undeniable fact that IC 1101 is such an enormous elliptical galaxy gently but firmly tells us that it has experienced so incredibly many mergers that any original graceful spiral structure it might have once possessed has been completely and forever erased. All of those ancient collisions, all of that intense gravitational chaos stretching over billions of years, has stirred up the 100 trillion stars just like someone slowly mixing fine ingredients in a vast cosmic bowl. What gently remains for us to observe today is this incredibly smooth, featureless giant, a glowing, silent testament to billions of years of relentless galactic consumption, floating peacefully in the dark and inviting us to quietly marvel at the immense passage of time. But there is something even more profoundly remarkable, and perhaps a little melancholy, about the current state of IC 1101, a paradox challenging our simple assumptions about size and vitality. Despite proudly containing an unimaginable 100 trillion stars within its massive boundary, it is actually fundamentally a dying galaxy. the stars that exist within it, are almost entirely old, ancient objects. Most of them are what dedicated astronomers call red giants or yellow stars, ancient stellar bodies that have already burned steadily through the vast majority of their nuclear fuel over the billions of years they have existed. Very few new, brilliant blue stars are being born anywhere inside the vast expanse of IC 1101 today. This undeniable scientific reality might seem incredibly strange at first glance. With so many hundreds of trillions of stars and so incredibly much accumulated mass, you might naturally expect IC 1101 to be a vibrant, glowing hotbed of stellar activity and constant rebirth. But we must gently remember exactly how it managed to grow so unfathomably large in the first place. Every single time it consumed another neighboring galaxy, it also greedily consumed that galaxy's precious supply of cold gas. Gas is the absolute, fundamental fuel required for all star formation in our universe. Without vast reserves of cold, collapsing gas, new, brilliant stars simply cannot be born into the darkness. Over billions of long, quiet years of relentless cannibalism, IC 1101 has completely used up or forcibly expelled almost all of its available star-forming gas. The violent, chaotic mergers themselves were often intense enough to rapidly heat the remaining gas to extreme, unimaginable temperatures, making it violently expand and escape the gravitational pull of the galaxy entirely. Or, alternatively, the gravitational shocks compressed the gas so very quickly that it all rapidly formed into billions of stars at once in brief, incredibly intense bursts of brilliant activity. Either way, the process unfolded. The ultimate end result is a massive galaxy that has completely run out of the vital, raw material needed to sustain its future. What quietly remains in the deep silence of space is a gentle, resting giant, slowly and inevitably fading into the dark cosmic night. The trillions of ancient stars that exist right now will faithfully continue to shine and provide light for billions of years to come. But as they each eventually quietly burn out and gently die, returning their ashes to the void, there will be absolutely no new, bright generations of stars to replace them. To truly grasp the sheer scale of this peaceful giant, imagine if you could somehow travel from one extreme edge of IC 1101 to the other. You would need to cross somewhere between 4 million and 6 million light years of nearly empty space. Remember, light travels at about 6 trillion miles per year. The Voyager 1 spacecraft, launched by NASA in 1977, is traveling through the dark at about 38,000 miles per hour relative to our Sun. To cross our entire Milky Way galaxy at Voyager, one's impressive speed would take about 2 billion years. But to slowly cross the entire expanse of IC 1101, you would need somewhere between 80 billion and 120 billion years. That is an amount of time significantly longer than our entire universe has even existed. Even with our fastest, most advanced spacecraft, crossing this single dying galaxy would be completely impossible. Wrapping our minds in a blanket of productive humility, IC 1101 is very much like an incredibly ancient kingdom that has successfully conquered all its neighbors, but finds itself with no children to carry on its grand legacy. It is staggeringly massive and utterly magnificent to behold, yet steadily approaching the quiet end of its active life. Thinking about this slow, graceful fade into the dark invites a profound sense of inner peace and intellectual humility within our own brief lives. We spend so much of our precious time worrying about small earthly concerns. But when we lift our minds to contemplate an ancient titan containing 100 trillion suns peacefully accepting the twilight of its existence. Our own daily anxieties gently begin to dissolve into the infinite, starry night. We are graciously reminded that everything in the cosmos has a beginning, a middle, and a quiet, beautiful end. This immense giant floating over 1 billion light years away serves as a majestic mirror for our own existence. It teaches us that true peace comes not from endless growth, but from simply being present in the beautiful, fleeting moment we are currently experiencing. IC1101 exists right now, allowing us the incredible privilege of understanding its long, ultimately peaceful history. We are a conscious part of a universe capable of building such massive structures out of nothing but gravity, time, and ancient star stuff. As we gently drift deeper into the very heart of this enormous galaxy on our journey together, we will soon discover that hiding at the exact quiet center of this fading behemoth is something even more mysterious and even more challenging to our human understanding than the 100 trillion stars that surround it, a profound mystery that waits patiently in absolute darkness. Have you ever peered into the absolute darkest, quietest shadows of a deep, silent forest and felt an inexplicable sense of wonder, realizing that the most profound mysteries often hide exactly where there is the least amount of light? As we continue our gentle journey deep into the vast ancient heart of IC1101, leaving the glowing outskirts of its 100 trillion stars behind, we approach a region of space that defies all ordinary human logic and gently challenges our fundamental understanding of reality itself. Sitting patiently in the absolute, silent center of this dying cosmic giant lies something even more incredible and majestic than the massive galaxy itself. At the very core of this fading titan rests one of the absolute largest known supermassive black holes in the entire infinite universe. To truly appreciate this gentle monster of the dark, we must first look back at our own quiet home. Every large, mature galaxy proudly holds a supermassive black hole at its central core. Our own beloved Milky Way possesses one, beautifully named Sagittarius A star, which quietly contains roughly 4 million times the mass of our warm, familiar sun. The dark, silent hole at the center of the neighboring Andromeda galaxy is significantly bigger, holding somewhere around 100 million to 200 million solar masses in its quiet grip. But the ancient black hole patiently sitting at the exact center of IC1101 exists in a completely, unimaginably different category of cosmic existence. Brilliant, dedicated scientists carefully estimate that this majestic black hole contains somewhere between 40 billion and 100 billion times the mass of our sun. Let us pause for a quiet moment and simply breathe with that staggering number, allowing its profound weight to generate a deep sense of peaceful humility. To put that vastness into a gentle perspective, this solitary black hole might easily possess 25,000 times more mass than the entire black hole sitting at the center of our entire Milky Way galaxy. Let me gently help you try to intuitively understand just how incredibly massive this truly is, without any academic intimidation. If you could miraculously weigh our entire planet Earth, you would find it has a mass of about 6 trillion kilograms. That sounds like a tremendously large amount until you gently compare it to our bright sun, which is roughly 330,000 times more massive than our Earth. Our sun is a fairly ordinary, quiet star by typical stellar standards. Now, take that magnificent sun and gently multiply its mass by 50 billion. That is roughly exactly how much total mass is irrevocably compressed into the silent, waiting supermassive black hole at the center of IC 1101. All of that unimaginable mass is crushed into a mysterious region of space from which absolutely nothing, not even a single whisper of light, can ever escape into the cosmic night. The inescapable, invisible boundary of a black hole is poetically called the event horizon. The physical size of this quiet, dark boundary entirely depends on the total mass contained within it. For a gargantuan black hole containing 50 billion solar masses, the event horizon would have a staggering radius of roughly 150 billion kilometers. That might sound enormous to our earthly ears, and it undeniably is, but we must remember that this is a region containing 50 billion times the mass of the Sun compressed into what is essentially an infinitely small point at the center. To truly anchor this vast number in our minds and find a sense of wonder in the scale, consider our own cosmic neighborhood. Our entire solar system, stretching all the way from the warm Sun to the freezing distant orbit of Neptune, is only about 9 billion kilometers across. The dark, silent event horizon of IC 1101 central black hole is roughly 16 times larger than our entire sprawling solar system. If you could miraculously take this ancient black hole and gently place it exactly where our Sun is right now, its dark, consuming event horizon would extend well beyond the distant, icy orbit of Pluto, silently and instantly engulfing absolutely everything we consider to be our cosmic home. It is a thought that gently humbles the human spirit, transforming our natural lack of understanding into a peaceful, respectful awe for the true scale of the universe. But what would it actually be like to quietly approach this monstrous silent black hole in the deep cosmos? The physical laws governing such extreme, ancient environments are incredibly bizarre, totally counterintuitive, and beautifully poetic in their absolute strangeness. Time itself, that steady, familiar river we all float upon, would pass entirely differently near the edge of the event horizon compared to being safely far away. If someone were to gently fall toward this massive black hole, they would mysteriously see the outside universe vastly speed up, like a beautiful, chaotic film on fast forward. Meanwhile, a quiet, outside observer safely watching from afar would see the falling person slowly down, appearing to completely freeze as they softly approach the dark horizon. From the safe outside perspective, the falling object would never actually seem to cross the final boundary into the void. Inside the event horizon itself, all physical directions lead inevitably, inescapably, toward the singularity lying at the very center. Space and time themselves become so intensely, beautifully warped that the very human concept of escaping becomes entirely meaningless. The singularity, a quiet point of theoretically infinite density, would gently but powerfully tear apart absolutely anything that dared to fall in, stretching it into long, incredibly thin strands through a fascinating, brutal physical process physicists have charmingly nicknamed spaghettification. But here is something profoundly remarkable and deeply comforting about this ancient cosmic titan. Despite its enormously terrifying size and its mind-bending absolute properties, the colossal black hole sitting at the center of IC 1101 is currently relatively quiet and peaceful. It is not actively, violently devouring huge amounts of stellar matter in the dark. There is no brilliantly glowing, spinning accretion disk swirling chaotically around it in the night. There is no incredibly powerful, brilliant jet of pure energy shooting outward into infinite space at nearly the speed of light. The black hole is simply there, quietly waiting in the dark silence, because it has already consumed almost all of the available material. that was easily within its vast gravitational reach over the past billions of years. This profound quietness is directly, intimately related to the exact same physical phenomenon that has peacefully stopped the rest of IC 1101 from forming any new brilliant stars. The vast majority of the cold, stellar gas in the entire galaxy has already been completely used up or blown away. And without vast rivers of gas slowly falling toward the center, the giant black hole simply has incredibly little left to eat. Occasionally, a stray ancient star wanders just a little too close in the dark and gets silently torn apart, providing a brief, lonely cosmic meal. But these violent events are incredibly rare in the modern, quiet era of this fading giant. The supermassive black hole, very much like the majestic, fading galaxy that hosts it, is a sleepy giant residing in deep repose, unimaginably powerful but beautifully, peacefully dormant. Yet, there are still haunting, silent traces of the black hole's incredibly violent, active past scattered through the surrounding darkness. Dedicated astronomers have carefully detected a glowing radio source at the very center of IC 1101, an echo of ancient energy. This radio emission originally comes from relativistic jets, which are powerful streams of particles forcefully accelerated to nearly the absolute speed of light and violently ejected from the immediate vicinity of the hungry black hole millions of years ago. These ancient jets were powerfully driven by the black hole's incredible rotation and its twisting magnetic fields, and they had the immense power to carve out enormous, silent cavities in the surrounding hot gas. Brilliant images from advanced X-ray telescopes show these vast, empty cavities clearly in the dark. They are essentially massive, silent bubbles of very hot, very thin gas blown outward by the staggering energy released near the black hole during its more active youth. Some of these ancient, ghostly bubbles are millions of light years across, serving as a silent, majestic testimony to intense periods in the deep past, when the black hole was vastly more active than it is today. The energy required to gently inflate these enormous cosmic bubbles is simply staggering, physically equivalent to the combined energy output of billions of individual stars over millions of quiet years. This magnificent history invites us to continue our journey, recognizing that the universe is an endless story of transformation. Have you ever marveled at how perfectly balanced a quiet ecosystem can be, where every living thing plays a vital role in maintaining a delicate, ongoing harmony? The universe, in its infinite wisdom, operates on a very similar principle of beautiful cosmic balance, even on the grandest scales imaginable. Scientists deeply believe that supermassive black holes play a profoundly crucial role in gently regulating the overall growth and evolution of their host galaxies. When cold gas flows inward toward a galaxy's center, the waiting black hole can release enough energy to rapidly heat that surrounding gas and forcefully push it outward, completely preventing it from collapsing and forming new stars. This process creates a kind of cosmic thermostat effect that quietly helps determine the final size and physical properties of the entire galaxy. In the case of IC 1101, this ancient feedback mechanism may be partly responsible for the galaxy's current fading state in the dark. The enormous black hole has actively helped to shut down star formation by intensely heating the available gas and preventing it from naturally cooling into new stellar nurseries. The giant galaxy and its quiet black hole have slowly reached a peaceful equilibrium, each one having deeply shaped the other over billions of years of shared, silent evolution. But how exactly did this central monster grow to contain 50 billion solar masses. Black holes patiently grow by slowly consuming the matter that gently falls into them over eons. When ancient galaxies merge in the cosmic night, the supermassive black holes resting at their quiet centers eventually find each other and merge as well. Over the incredibly long course of IC 1101's history of galactic cannibalism, its central black hole has been faithfully fed again and again by the dark. Every single time that IC 1101 consumed another wandering galaxy, it also added to the overall mass of this growing monster. Every single merger brought in more raw fuel for the black hole's insatiable appetite. The actual physical process by which two supermassive black holes merge in the dark is absolutely fascinating, immensely violent, and completely hidden from our human eyes. When two massive galaxies slowly collide, their central black holes do not immediately find each other in the chaos. They are initially separated by vast distances and completely surrounded by billions of brightly burning stars. But as the long merger steadily progresses over hundreds of millions of years, the persistent gravitational friction with the surrounding sea of stars causes the two black holes to slowly, inevitably spiral toward the exact center of the newly combined galaxy. Eventually, these two ancient black holes get close enough to form a binary system, continuously and silently orbiting around each other in the deepest dark. As they quietly orbit in their gravitational embrace, they steadily lose precious energy through the emission of gravitational waves, which are invisible ripples in the very fabric of space-time itself. These mysterious waves quietly carry kinetic energy entirely away from the binary system, gracefully causing the orbit to shrink tighter. The two massive black holes spiral closer and closer together, orbiting faster and faster through the dark until they inevitably merge in a catastrophic cosmic event that instantly releases staggering amounts of energy. When two supermassive black holes finally merge, the invisible gravitational waves they produce are among the most energetic events in the entire universe. The final merger releases vastly more energy than all of the billions of stars in a typical galaxy combined, though almost all of this incredible energy is in the form of stretching space-time rather than visible light. These silent waves ripple outward at the speed of light, gently stretching and squeezing space itself as they pass through the cosmos, eventually washing over our Earth billions of years later. We humans have only very recently developed the technology needed to actually detect these ghostly gravitational waves. The very first direct detection came in the year 2015, when the LIGO observatories measured the faint waves from two stellar mass black holes merging a billion light-years away. Since that profound moment of discovery, dozens of incredible gravitational wave events have been carefully observed, beautifully opening up an entirely new way of studying the universe without relying on light. Future gravitational wave detectors like the planned LISA mission that will one day fly silently in space will finally be able to easily detect the massive mergers of supermassive black holes across the universe. When LISA successfully launches, perhaps in the 1930s, it might detect cosmic events incredibly similar to the ancient mergers that slowly built up IC 1101's central black hole, allowing us to literally listen to the universe as giant black holes collide. IC 1101's black hole has experienced dozens of such profound mergers over its incredibly long history. Each gentle merger added immense mass and slightly altered the black hole's invisible spin. The chaotic process of multiple mergers also deeply affected the surrounding galaxy, as the wildly orbiting black holes forcefully flung nearby stars outward through intense gravitational interactions. This fascinating process known as gravitational scouring is exactly why IC 1101's central core is so large, yet relatively faint and underpopulated. Repeated black hole mergers have systematically scattered billions of stars away from the very center, quietly creating a core profile that is unusual for galaxies of this staggering size. The mysterious core of IC 1101 is truly remarkable for its sheer size. A study conducted in the year 2017, using breathtaking images from the Hubble Space Telescope, carefully measured the galactic core and discovered that it stretches across nearly 14,000 light-years. That number means just the central core alone, not the whole massive galaxy, but simply the innermost region, is vastly bigger than most entire dwarf galaxies. This core quietly contains more ancient stars than most complete galaxies that we can observe. Now, I want to gently take you on a thoughtful journey of perspective to help you truly appreciate this staggering scale, allowing the vastness to inspire a sense of peaceful awe. Imagine if you could somehow shrink our entire Milky Way galaxy down to the exact size of a simple dinner plate, measuring about 10 inches across. On that vastly reduced scale, IC 1101 would be the size of a large swimming pool. Our entire beautiful galaxy, with all of its hundreds of billions of stars and the elegant spiral arms where we safely make our home, would be just a tiny, insignificant dish gently floating in a vast sea. Or deeply consider this quiet truth. Light from IC 1101 has traveled for over 1 billion years to reach us through the dark. In all that immense time, ancient light has been continuously streaming away from this galaxy in every direction. Every single second, IC 1101 radiates enough light to travel about 186,000 miles. Over 1 billion years, that light has traveled 1 billion light years, which is roughly 6 billion trillion miles. And it is only now, at this exact moment in history, arriving at the polished mirrors of our telescopes, ancient photons that first left their distant home when our Earth was still in its primitive stages of complex life. The deeply humbling discovery and careful study of IC 1101 would not have been possible without tremendous advances in our human telescope technology. In the early, quiet days of astronomy, primitive telescopes were strictly limited by the sheer physical size of their glass lenses and mirrors. Larger telescopes could naturally gather more faint light and see fainter objects in the dark, but there were practical limits to exactly how big you could successfully make a telescope on the ground. The Earth's swirling atmosphere also constantly posed a massive blurring problem. Earth's protective atmosphere is fluidly moving and softly shimmering, which is exactly why the distant stars appear to gently twinkle in the night. This romantic twinkling terribly blurs the delicate images that ground-based telescopes can capture, limiting how clearly they can ever see distant, ancient objects. For most of the 20th century, astronomers could plainly see that IC 1101 existed and was indeed very large, but they simply could not study its intricate, detailed structure. Absolutely everything miraculously changed with the historic launch of the Hubble Space Telescope in the year 1990. Floating peacefully and silently above the blurring atmosphere, Hubble could suddenly capture breathtaking images with incredible, unprecedented clarity. Over the quiet decades since its launch, Hubble has patiently observed IC 1101 multiple times, gracefully revealing hidden details about its massive core, its surrounding halo of ancient stars, and its complex gravitational relationship to the other galaxies in its cluster. Have you ever found an old, faded photograph safely tucked away in a quiet drawer, and felt that profound, almost magical sensation of holding a frozen fragment of the ancient past gently in your hands? When we look up at the infinite night, we are engaging in this exact same, deeply human act of remembering, only on a vastly grander cosmic scale. As we continue our quiet journey to understand the majestic giant known as IC 1101, we must deeply appreciate that human vision alone is simply not enough to unravel the universe's most profound secrets. More recently, dedicated astronomers have creatively used a magnificent variety of other specialized telescopes to deeply study IC 1101 at entirely different, invisible wavelengths of light. Radio telescopes, resembling massive silent ears pointed toward the heavens, have successfully detected the faint, lingering emission from its central black hole, a quiet ghost of its violent past. The Chandra X-ray Observatory, drifting peacefully above our atmosphere, has carefully mapped the invisible, super-hot gas that completely fills the massive cluster safely surrounding it, revealing the energetic environment in which this giant galaxy silently lives. The Spitzer Space Telescope gently observed the galaxy in the warm glow of infrared light, piercing through obscuring dust to gracefully detect the soft, dying light of the older, cooler stars that heavily dominate the bodies of massive elliptical galaxies. Each new telescope, observing patiently at entirely different hidden wavelengths, gently adds another crucial piece to the vast, complex puzzle, allowing us to slowly build a more complete understanding of this ancient cosmic giant resting in the dark. But we do not always have to leave our precious fragile Earth to gaze deeply into the infinite void. Ground-based telescopes, safely anchored to our spinning world, have also improved dramatically, gracefully overcoming the very limitations that once held us back. Modern, quiet observatories perched on high, lonely mountain peaks now intelligently use a brilliant technique called adaptive optics. This remarkable technology uses constantly deformable mirrors and powerful guiding lasers to continuously correct for the natural blurring distortion of our planet's atmosphere in absolute real time. The breathtaking result is a series of incredibly sharp images that remarkably approach the pristine quality of space-based observations, but they are gathered from massive ground-based telescopes that can be built much larger than absolutely anything we could currently launch into the silent orbit. The largest, most advanced ground-based telescopes operating today possess gigantic curved mirrors more than 30 feet across, patiently gathering enormous amounts of ancient light from the darkness. These quiet, mechanical giants are uniquely able to gracefully detect celestial objects billions of times fainter than the unaided human eye could ever hope to see. These magnificent instruments can carefully observe IC 1101 in exquisite, staggering detail, meticulously measuring the slow motions of its ancient stars, deeply analyzing the complex chemical composition of entirely different parts of the massive galaxy, and tracking any subtle, quiet changes over vast expanses of time. Even more incredibly powerful, awe-inspiring telescopes are currently on the way, promising to gently pull back the dark curtain of the cosmos even further. The James Webb Space Telescope, which was triumphantly launched into the cold dark in late 2021, has already successfully begun observing distant, ancient galaxies with unprecedented, breathtaking sensitivity in warm, infrared light. Looking toward the future of our quiet journey of discovery, the extremely large telescope, currently under careful construction in the high, dry deserts of Chile, will boast a colossal mirror measuring nearly 130 feet across when it finally sees its very first ancient light in the late 2020s. These staggering futuristic instruments will beautifully allow us to study IC 1101 and other magnificent galaxies just like it in even greater, unprecedented detail. They will gently help us peer deeper into the profound mystery of how such immense structures naturally form and gracefully evolve over the long, silent eons of cosmic time, bringing us closer to understanding our own origins in the universe. But there is also the profound fundamental question of exactly how we measure the immense distances to celestial objects as incredibly far away as IC 1101. Physical distance is absolutely one of the most fundamental, crucial quantities in all of astronomy, but it is also undeniably one of the absolute hardest things to accurately measure in the infinite silence of space. How do you accurately tell exactly how far away something truly is when you simply cannot travel there and stretch out a physical measuring tape across the void? For relatively nearby, familiar celestial objects within our own galaxy, astronomers gently use a clever geometric technique known as parallax. As our Earth quietly orbits the bright sun each year, our visual perspective on nearby stars changes very slightly. By carefully measuring exactly how much a star appears to gently shift against the distant, unmoving background of far-off stars over the long course of a single year, astronomers can beautifully calculate exactly how far away it is. This elegant method works perfectly well for stars located safely within a few thousand light-years of our quiet home. But for much more distant objects sitting in the deep cosmos, the parallax shift is simply too tiny, too infinitely small to ever measure, even with our most incredibly precise modern instruments. For these vast, extreme cosmic distances, astronomers must gently rely on a beautiful, conceptual tool known as the cosmic distance ladder, a brilliant series of overlapping techniques that carefully build upon each other, allowing us to slowly step out into the infinite unknown. One crucial rung of this cosmic ladder gently involves a very special type of star called a Cepheid variable. These remarkable stars pulsate in their brightness in a very regular, highly predictable pattern, and the exact period of their slow pulsation is directly, mathematically related to their true intrinsic luminosity. By carefully measuring exactly how bright a distant Cepheid appears from Earth and precisely how fast it pulsates in the dark, astronomers can gracefully calculate exactly how far away it is. These beating stellar hearts can be seen in galaxies tens of millions of light years away, but the majestic IC 1101 is vastly too distant even for this incredibly clever technique. At a staggering distance of over 1 billion light-years, any individual Cepheid stars residing within it are far, far too faint for our current telescopes to ever detect in the deep cosmic night. For such mind-bending extreme distances, astronomers must gently rely on even brighter, more catastrophic standard candles. One of the most absolutely important of these cosmic markers is a specific type of violently exploding star, poetically known as a Type 1, a supernova. These brilliant explosions beautifully occur when a small, dense white dwarf star greedily accumulates entirely too much matter from a nearby companion star and suddenly detonates in a colossal thermonuclear explosion. Because the precise physical conditions required for this massive detonation are incredibly similar from one supernova to another across the universe, they all reliably reach roughly the exact same peak brightness in the dark. By carefully measuring exactly how bright a distant Type 1a supernova appears from our Earth. Astronomers can effectively estimate exactly how far away its ancient host galaxy truly is. Another profoundly beautiful technique involves carefully measuring the delicate redshift of a distant galaxy's ancient light. As the vast universe continuously expands, the very fabric of space stretches out, and the light traveling from distant, ancient objects gets gently stretched to longer and longer wavelengths over the eons. This physical stretching gracefully shifts the visible light toward the red end of the color spectrum, hence the poetic name, redshift. The more incredibly distant an object is in the quiet cosmos, the more the entire universe has expanded since its ancient light was first emitted, and therefore the greater its measured redshift will be. By carefully measuring the specific redshift of the ancient light arriving from IC 1101, dedicated astronomers have mathematically determined that it is roughly 1.04 billion light-years away. This staggering measurement, gently combined with careful observations of the massive galaxy's apparent size and overall brightness in the dark sky, beautifully allows them to calculate its true physical properties, like its incomprehensible diameter and its immense stellar mass. Each of these remarkable human techniques naturally carries some gentle uncertainties, and measuring vast cosmic distances is never a perfectly simple matter. Astronomers quietly continue to refine their beautiful methods using brand new observations and an ever-improved understanding of the deep underlying physics. The exact distance to IC 1101 might gently be revised as even better, more precise data naturally becomes available. But the basic, awe-inspiring picture of an enormous, fading galaxy sitting over 1 billion light-years from our Earth is extremely well established in the silence of space. I also deeply want to talk about the profound philosophical meaning of observing something that is an incredible 1 billion light-years away, an idea that naturally invites a deep sense of peaceful contemplation. When we look at IC 1101, we are absolutely not seeing the giant galaxy as it truly is today. We are gently seeing it as it was over 1 billion years ago in the deep past, back when the ancient light we detect today first began its incredibly long, quiet journey toward our distant Earth. Let your mind peacefully wander back to what our own world was like 1 billion years ago. Earth was a profoundly, vastly different place in the ancient dark. Complex, intelligent animal life had absolutely not yet evolved upon its surface. The quiet planet was peacefully populated almost entirely by simple, single-celled organisms, and perhaps the very simplest forms of multicellular life, but absolutely nothing that would be easily recognizable to us today as a familiar animal or a tall plant. The ancient continents were in completely different, unfamiliar positions, gathered together in alien configurations that would be entirely unrecognizable to a modern observer looking down from space. The primordial atmosphere itself had a completely different chemical composition. It was, by any measure, an entirely alien world drifting in the silence. During absolutely all of the immense, unfathomable time that has passed since then, the faint light from IC 1101 has been continuously traveling through the dark, cold vacuum of space. It silently crossed the vast emptiness between countless galaxies, occasionally passing gracefully through invisible clouds of intergalactic gas, or being bent slightly by the powerful, gentle gravity of intervening cosmic objects. It traveled faithfully at the absolute fastest speed anything can possibly travel in the universe. Yet, the physical distance was so incredibly immense that it took over 1 billion years just to safely arrive. The beautiful IC 1101 that we see so clearly in our advanced telescopes today might actually be very, very different from the IC 1101 as it truly exists right now in the present moment. Over 1 billion years of deep time, much could have gently changed in the dark. Trillions of ancient stars that were shining brightly then might have quietly burned out by now, fading away into nothingness. New stars might have occasionally formed from the last whispers of cold gas. The silent, supermassive black hole at its core might have experienced brief, new feeding events or gone through extended periods of profound dormancy. Other, smaller galaxies that were slowly falling toward IC 11011 billion years ago might have been completely consumed by now. We have absolutely no way of knowing what IC 1101 truly looks like at this very exact moment. The new information about its current state will not reach us for another 1 billion years. In a very real, poetic sense, we are the quiet archaeologists of the cosmos, peacefully studying the ancient past rather than the immediate present. Every single observation of a distant cosmic object is a gentle look backward in time, a beautiful glimpse of how things used to be rather than how they are right now. This inevitable time delay is both a humbling limitation and a profound, beautiful opportunity for the curious human mind. It limits our ability to perfectly understand the current state of the vast universe, but it generously allows us to study deep cosmic history directly by simply looking at galaxies sitting at different distances, and therefore at entirely different sequential points in the ancient past. Dedicated astronomers can beautifully piece together how galaxies have gracefully changed over the eons of cosmic time. We can peacefully see what galaxies looked like when the universe was still very young, gently compare them to more recent examples, and trace the magnificent evolution of cosmic structures over billions of years. IC 1101, seen clearly as it was 1 billion years ago, provides a majestic snapshot of a giant galaxy in a very particular stage of its long evolution, offering us a profound sense of connection to the ancient, unfolding story of our beautiful cosmos. Have you ever sat quietly on a sandy beach, scooping a handful of tiny grains into your palm, and wondered how our human minds can comprehend the true scale of the infinite universe? The numbers we have been discussing on this journey are so vast that they naturally become abstract to our earthly senses. 100 trillion ancient stars, 4 million to 6 million light years across, 1 billion years of deep time. These are numbers that our human brains evolved to handle poorly in our daily lives. We are adapted for counting small groups, measuring familiar distances we can walk in an afternoon, and tracking time spans of changing seasons and generations. Absolutely nothing in our ancient evolutionary history prepared us for the true cosmic scale of the universe. So, let us try a few more thought experiments to help make these vast numbers feel a little more real, anchoring our sense of wonder in something we can touch with our imagination. Imagine that you wanted to take a single photograph of every single star residing in the vast expanse of IC 1101. You possess a camera that can snap exactly one picture every single second, and you never need to rest, sleep, or take a break in the dark. How long would it take you to photograph all 100 trillion stars? The humbling answer is over 3 million years of continuous, silent photography. If you had started taking these pictures when the very first humans evolved on the ancient Earth, you would still have millions of years of photography lying ahead of you in the dark. Or consider this gentle comparison to the familiar shores of our home world. the tiny, sparkling grains of sand resting on all of the beaches of Earth number perhaps in the hundreds of trillions. IC 1101 peacefully contains roughly as many ancient stars as there are individual grains of sand on every single beach on our entire beautiful planet. Each of those distant stars is a massive, glowing nuclear furnace, quietly burning ancient hydrogen into helium, releasing energy that streams outward in every direction through the silent cosmos. Each one might have small, rocky planets. Each one has a long story, a deep history, and a quiet future unfolding in the night. Now, imagine trying to take a peaceful walk completely across the entire expanse of IC 1101. The average human walking speed is about 3 miles per hour. At that relaxed, steady pace, walking 24 hours a day without ever stopping to rest in the quiet night. It would take you about 50 trillion years just to walk from one outer edge of IC 1101 to the exact opposite side. That is over 3,000 times longer than the current age of our entire universe. You could walk for the entire history of absolutely everything that has ever happened from the ancient Big Bang until right now, and you would have covered less than 1/13,000th of the total distance across this single, fading galaxy. Or think about the fundamental concept of communication in the vast silence. Light is the fastest thing in the entire universe, traveling effortlessly at about 670 million miles per hour through the dark vacuum. A single message sent by a gentle beam of light from one extreme side of IC 1101 would take between 4 million and 6 million years just to finally reach the other side. If a peaceful civilization living quietly on one edge of IC 1101 decided to send a friendly message to another civilization resting on the opposite edge, the receiving civilization would not get the message for millions of years, and any warm reply would naturally take millions of years more to return across the silence. Simple communication across this majestic galaxy would unavoidably span deep geological time scales. These quiet thought experiments do not magically make the massive numbers perfectly graspable. Perhaps nothing can successfully do that, as the human mind simply is not built for such extreme cosmic scales. But they can gently give us a profound sense of the vastness, a humbling feeling deep in our gut, transforming our natural ignorance into a peaceful motivation to continue learning. Let me now turn to a beautiful, profound question that might very well be quietly resting on your mind right now. If the ancient galaxy of IC 1101 is truly so enormous, are there mysterious aliens living peacefully there in the dark? Could a magnificent galaxy that contains 100 trillion stars be a vast, welcoming home to intelligent life? This is exactly the kind of profound question that modern science cannot answer directly right now in the deep silence. We currently have absolutely no way of miraculously detecting life in distant, ancient galaxies. We barely have the advanced technology to safely look for life within our own quiet solar system, let alone in galaxies sitting 1 billion light-years away in the deep cosmos. But we can peacefully think about what the staggering numbers suggest to us. If fragile life naturally requires rocky planets, and those planets safely orbit warm stars, then a massive galaxy with vastly more stars should naturally have vastly more potential homes for life to emerge. The familiar Milky Way might hold somewhere between 100 billion and 400 billion planets drifting in the dark. If even a remarkably tiny fraction of those planets are physically suitable for life, there could easily be millions of unseen worlds teeming with living things in our home galaxy alone. Now, scale that vast thought up to the majestic expanse of IC 1101. With 100 trillion ancient stars, this colossal galaxy could easily boast hundreds of trillions of silent planets, even if only exactly 1 in a billion of those distant planets successfully developed life. That would still mean hundreds of thousands of living, breathing worlds floating in the deep night. Even if only exactly 1 in a trillion gently developed intelligent life, capable of peacefully building civilizations and looking up at the stars, that would still mean 100 brilliant civilizations residing within IC 1101. Of course, we must humbly remember that these staggering numbers are based on deep assumptions that we simply cannot verify from our distant vantage point. We truly do not know exactly how common, delicate life is in the infinite universe. We do not know how often simple life gracefully develops deep intelligence. We do not even know for certain that life strictly requires rocky planets exactly like ours, or that it necessarily requires liquid water, or that it is absolutely based on carbon. The beautiful diversity of physical conditions in the vast universe might easily be matched by a profound diversity of strange, wonderful forms that life can creatively take in the dark. What we can peacefully say with gentle confidence is that IC 1101 effortlessly offers an enormous canvas for whatever mysterious processes might gracefully lead to life. A massive galaxy of that staggering size has been quietly producing stars for billions of years in the silence. Essential heavy elements, the beautiful carbon, oxygen, and iron that living things desperately need to exist, have been carefully manufactured in the hot stellar cores and peacefully scattered through colossal supernovas countless times in the ancient dark. Whatever the secret recipe for life might truly be, IC 1101 has possessed vast resources and enormous amounts of deep time to patiently cook it up. And if intelligent life does indeed exist deep within IC 1101, what might they think when they quietly look up at their own alien night sky? Their view of the cosmos would be very different from ours, where we see a relatively sparse, quiet field of stars with a gentle band of the Milky Way gracefully stretching across the heavens. They would see brilliant, ancient stars absolutely everywhere, in every single direction they looked. The natural density of stars in an ancient elliptical galaxy like IC 1101 is vastly higher than in the flat disk of a spiral galaxy like ours. Near the massive, silent center of IC 1101, the night sky would be absolutely ablaze with eternal light. Stars would crowd so incredibly closely together that there might not be any true darkness at all on their quiet worlds. The combined soft glow of billions upon billions of extremely nearby stars would fill their sky with a beautiful, perpetual twilight. Peaceful navigation by the stars across their oceans would be nearly impossible because there would simply be far too many stars to easily distinguish one from another in the glowing expanse. Further out from the massive center, physical conditions would be somewhat more like what we experience, but still profoundly different. No graceful spiral arms would trace beautiful patterns across their sky. No bright central band of light would quietly mark the flat plane of a galactic disk. Instead, the ancient stars would be peacefully distributed in a more spherical pattern, completely surrounding any quiet observer in a gentle, glowing shell of stellar light. Would such peaceful beings know about the violent, long history of their majestic galaxy? Would they have beautifully discovered that their massive home was built slowly from the ancient remains of dozens of smaller galaxies consumed over billions of years in the deep dark? Would they have cleverly detected the enormous, supermassive black hole resting at their galaxy's absolute center? Or figured out that their cosmos was billions of years old? we simply cannot know for sure. But it is fascinating to think that somewhere deep inside IC 1101, on exactly one of hundreds of trillions of possible quiet planets, intelligent beings might be asking the exact same profound questions about the universe that we ask here on our Earth. They might be quietly looking out at the surrounding dark space, seeing other distant galaxy clusters in the distance, gently wondering if those faint smudges of light contain other curious minds. They might have even detected our own Milky Way galaxy, though from their vast perspective, it would simply be just another unremarkable spiral galaxy among billions in the dark. The infinite universe is vastly grand beyond human comprehension, and the beautiful possibilities it holds are equally peacefully vast. Every single galaxy we gently study reminds us of this profound vastness and quietly challenges us to deeply think about our peaceful place within it. As we continue this quiet journey, I want to take some peaceful time to explore more about the beautiful, complex environment that safely surrounds IC 1101 in the deep dark, because absolutely no galaxy ever exists in complete, silent isolation. IC 1101 sits majestically at the exact heart of the enormous Abell 2029 galaxy cluster, and deeply understanding this specific cluster beautifully helps us understand exactly why IC 1101 became so incredibly enormous in the very first place. Galaxy clusters are some of the largest gravitationally bound structures in the entire universe. They can easily contain hundreds or even thousands of individual galaxies, all gracefully orbiting around a common center of mass in the deep, silent void. The vast space safely floating between galaxies in a massive cluster is absolutely not completely empty. It is beautifully filled with extremely hot, invisible gas, naturally heated to staggering temperatures of tens of millions of degrees by the immense gravitational energy released as the ancient cluster first formed. Have you ever watched a gentle autumn leaf slowly, silently fall to the quiet forest floor, drawn by an invisible force, and wondered how the entire vast universe is gracefully governed by that very same inescapable pull? As we deepen our peaceful exploration of the immense Abell 2029 galaxy cluster, we find a beautiful cosmic demonstration of gravity's patient, eternal work in the dark. This magnificent cluster is exactly what dedicated astronomers peacefully call a relaxed cluster, a poetic term meaning it has slowly, gracefully settled into a fairly stable, harmonious configuration over billions of years of silent cosmic time. The hundreds of individual galaxies resting within it have had ample time to gently sort themselves out in the dark, with the absolute most massive ones slowly sinking toward the exact center due to a fascinating, beautiful physical process called dynamical friction. As more massive, heavy objects move deliberately through a vast cosmic sea of much smaller objects, they experience a gentle kind of gravitational drag that slowly saps their energy, softly slows them down, and causes them to inevitably spiral inward toward the deepest part of the cosmic well. IC 1101 sits majestically at the very absolute bottom of this profound gravitational well, resting peacefully at the densest part of the ancient cluster, where countless galaxies are packed most tightly together in the silence. This privileged location is absolutely not a simple coincidence of the night. IC 1101 grew so incomprehensibly large, precisely because it was safely anchored in this central, commanding position. As other smaller galaxies spiraled inevitably toward the cluster's center over the eons, drawn by the irresistible pull of destiny, they encountered the waiting IC 1101 and were quietly, seamlessly absorbed into its massive, glowing body. The exact same gentle, relentless process that brought IC 1101 to the absolute center also provided it with a constant, steady supply of cosmic victims to consume in the dark. The extremely hot, invisible gas that completely fills the vast spaces of the cluster also plays a profoundly beautiful role in IC 1101's long, quiet evolution. This ethereal gas, which scientists poetically call the intra-cluster medium, is incredibly, almost unimaginably sparse by our normal earthly standards. If you could miraculously reach out into the void and scoop up a single cubic meter of it, you would find only a few solitary atoms drifting in the dark. But because there is simply so incredibly much of it spread over millions of light years of empty space, it gently adds up to an enormous, staggering amount of total mass. This invisible gas is so intensely hot that it naturally emits high-energy X-rays, which is exactly how our clever, orbiting astronomers carefully detect it. Advanced X-ray telescopes, like NASA's brilliant Chandra Observatory, have meticulously mapped the graceful distribution of this super-hot gas in Abel 2029, beautifully revealing that it is heavily concentrated exactly around IC 1101 at the cluster's very center. The glowing gas forms a kind of vast protective atmosphere around the giant, sleeping galaxy, a thin, ethereal haze of super-hot particles extending millions of light years into the silent space. The continuous, quiet presence of this hot gas has profound implications for IC 1101's ultimate future in the dark. Over immense periods of cosmic time, hot gas can naturally cool down, slowly radiating away its vast energy as glowing X-rays. When it cools enough in the silence, it can gently fall back into the central galaxy, potentially fueling a magnificent, brilliant new era of star formation. In some other distant galaxy clusters, astronomers have beautifully observed enormous flows of cooling gas representing hundreds of solar masses worth of material per year, streaming gracefully into the central galaxy. But in the quiet, specific case of IC 1101, something mysterious seems to be completely preventing this gentle cooling flow from successfully igniting a new, beautiful burst of starlight. The leading scientific theory is that the supermassive black hole resting at IC 1101's exact center is directly responsible for this quiet, peaceful dormancy. When cooling gas naturally falls toward the waiting black hole, some of it gets intensely heated up and violently blown back out into the vast cluster. This creates a beautiful, delicate feedback loop where the silent black hole carefully regulates the surrounding gas supply, entirely preventing too much cold material from accumulating and forming new, bright stars. We can actually see clear, haunting evidence of this ancient feedback mechanism in our precise observations of IC 1101 and its quiet surroundings. There are massive, silent cavities resting in the hot gas around the galaxy, enormous bubbles that have been forcefully blown outward by powerful jets from the central black hole during its ancient, more active youth. These silent cavities are millions of light years across, enormous empty voids carved out of the delicate intra-cluster medium by the staggering energy output of the black hole. This elegant feedback mechanism is widely thought to be absolutely critical for understanding exactly why massive, ancient elliptical galaxies like IC 1101 are not actively forming any new stars today. Without the central black hole quietly acting as a cosmic thermostat, regulating the gas supply, massive cooling flows would easily deliver enough fresh material to trigger substantial, brilliant star formation across the galaxy. But the silent black hole patiently maintains the balance, heating up the gas whenever too much starts to cool, gracefully keeping the giant galaxy in a kind of permanent, peaceful energy balance. The delicate, ongoing interplay between these giant galaxies their resting black holes, and the hot gas in galaxy clusters remains one of the absolute most active, fascinating areas of deep research in modern astrophysics, gently inviting us to marvel at the complex harmony of the cosmos. Let me now gently take you through a sweeping, majestic timeline of IC 1101's long history, as best as our human minds can carefully reconstruct it from precise observations and brilliant theoretical models. This quiet timeline spans billions of years and involves physical processes that are profoundly difficult to truly imagine, yet deeply beautiful to contemplate. Understanding this vast unfolding story gently helps us appreciate exactly how this cosmic giant came to gracefully exist in the dark. The epic story softly begins about 13 billion years ago, not very long after the ancient Big Bang itself illuminated the void. The primitive universe at that specific, quiet time was profoundly, vastly different from what we peacefully see today. There were absolutely no majestic galaxies yet, just vast, endless clouds of simple hydrogen and helium gas left over from the very first chaotic few minutes of cosmic history. These ancient primordial clouds were not perfectly, smoothly uniform across the silence. Some tiny regions were just slightly denser than others, and the gentle, persistent pull of gravity began to slowly draw these denser regions together in the dark. Over the very first few 100 million years of silent cosmic time, these denser regions quietly collapsed to lovingly form the very first brilliant stars and the absolute first primitive galaxies. These early, ancient galaxies were remarkably small, irregular collections of glowing stars looking absolutely nothing like the grand sweeping spirals and massive ellipticals we peacefully observe today. They formed specifically in the absolute densest parts of the cosmic web, the vast, invisible network of glowing filaments and dark nodes that beautifully define the large-scale structure of our entire universe. The specific, quiet region of space that would eventually become the massive Abell 2029 cluster was one of these incredibly dense, privileged regions. Many small, bright galaxies gently formed there, and they almost immediately began interacting with each other in a slow, cosmic dance. Mergers happened very frequently in the ancient, early universe, when galaxies were physically much closer together, and the entire cosmic web was vastly more compact than it is today. One of those early, quiet galaxies, or more likely a chaotic merger product of several early galaxies, was the ancient ancestor of IC 1101. We simply do not know exactly what this ancient proto-galaxy looked like in the dark, but it was probably a chaotic collection of a few billion stars, maybe measuring 100,000 light-years across, with a slowly growing black hole waiting at its center. Over the next several billion years, this restless proto-galaxy experienced merger after major merger in the silence. Each time a smaller wandering galaxy ventured too close in the night, gravity patiently captured it and eventually absorbed it completely. Each violent merger added millions of stars and vast clouds of gas, and each merger faithfully fed the growing central black hole. The galaxy grew larger and incredibly larger, and its anchored position at the exact center of a dense cosmic region practically ensured a constant, steady supply of smaller victims. By about 10 billion years ago, the ancient ancestor of IC 1101 had probably already become a giant elliptical galaxy, having successfully experienced dozens of major violent mergers. It would have been one of the absolute largest galaxies in its specific part of the ancient universe even then, though not yet as incredibly, staggeringly massive as it is today. The next several billion years peacefully saw continued, steady growth, though at a gradually slower, more relaxed pace. The most intense, chaotic period of galaxy formation was slowly winding down across the entire universe. Star formation rates were quietly declining as ancient galaxies steadily used up their precious gas supplies in the dark. Mergers became vastly less frequent as the relentless expansion of the universe slowly carried the remaining galaxies farther and farther apart. But IC 1101 remained safely anchored in a very special, privileged location. The massive Abel 2029 cluster had slowly grown and matured, and IC 1101 sat patiently at its beating heart. Wandering galaxies continued to slowly fall toward the cluster's dark center, irresistibly drawn by the enormous combined gravity of all the gathered matter there. And when they finally reached the deep center, they encountered the waiting IC 1101. During this long, quiet period, IC 1101 probably experienced another 20 or 30 major mergers, along with countless minor, silent ones. Each merger added to its staggering mass. Each merger violently stirred up its ancient stars. Each merger dutifully fed its already enormous silent black hole. By about 5 billion years ago, around the exact time our own quiet sun was just beginning to gently form from a cloud of dust, IC 1101 had already grown to something incredibly close to its current magnificent size. It contained tens of trillions of stars peacefully spread across millions of light years of dark space. Its central black hole had grown to tens of billions of solar masses, and it had essentially run out of easy, wandering prey. The remaining galaxies in the vast cluster were either too far from the center to be captured easily, or were permanently locked in stable, distant orbits that would take many more billions of years to slowly decay. IC 1101 had successfully consumed almost everything it could possibly consume. Its chaotic days of rapid, violent growth were finally peacefully over. What gently remains today is exactly what we observe through our telescopes. A dying, resting giant, still enormous, still utterly magnificent, but no longer rapidly growing. Its trillions of stars are old and tired. Its star-forming gas is completely depleted. Its massive black hole is relatively quiet, occasionally flaring up when a tiny bit of gas wanders too close, but mostly remaining deeply dormant in the silent dark. IC 1101 has reached something beautifully akin to a steady state, slowly and gracefully fading as its ancient stars burn out one by one. This sweeping, majestic history gently invites us to marvel at the infinite patience of the cosmos, providing a profound sense of inner peace. Have you ever stood in an empty, quiet room and felt the profound, invisible presence of the air around you, wondering about the unseen forces that gently shape our physical reality? This history of IC 1101 is absolutely not entirely unique, but it represents an extreme, breathtaking case of a majestic galaxy that was perfectly positioned to grow to truly exceptional proportions in the dark. It is an awe-inspiring message from the ancient universe about its very own fundamental nature. The vast universe is deeply, beautifully hierarchical in its elegant construction. Small, simple things gradually, inevitably, combine to make larger, more complex things in the silence. Invisible atoms form glowing stars. Burning stars form massive galaxies. Sweeping galaxies form enormous clusters. And massive clusters form unimaginable superclusters. This majestic hierarchical structure is one of the absolute defining features of the beautiful cosmos we peacefully inhabit, a profound consequence of exactly how the invisible force of gravity operates over immense stretches of cosmic time. IC 1101 beautifully represents the absolute upper end of this grand hierarchy for individual galaxies. While there may be vastly larger overall structures in the silent universe, such as vast glowing walls and intricate filaments of galaxies stretching for hundreds of millions of light years through the dark, when it comes to single, cohesive objects bound tightly together by their own internal gravity. Giant elliptical galaxies like IC 1101 are essentially as big as it physically gets. Understanding these natural limits of cosmic structures gently teaches us about the deep underlying physics of the entire universe, inspiring a quiet sense of wonder. The undeniable fact that IC 1101 is about 4 million to 6 million light-years across, rather than a staggering 1 billion light-years across, quietly tells us something incredibly profound about how gravity, mysterious dark matter, and cosmic expansion all elegantly balance against each other in the deep night. If absolutely any of these fundamental factors were even slightly different, the absolute largest galaxies might be vastly larger or incredibly smaller than what we actually peacefully observe today. By quietly studying this distant, fading giant, we intimately learn about the invisible rules that govern absolutely everything, from the smallest vibrating atoms to the largest sweeping cosmic structures. We learn exactly how deep time, silent gravity, and pure energy have beautifully shaped the cosmos over billions of years. When we realize that even the largest cosmic objects are deeply bound by the exact same physical laws that naturally govern the gentle falling of a raindrop on our quiet earth, we feel a profound, comforting sense of connection to the vastness, gently replacing any earthly anxieties with a serene acceptance of our beautiful place in the mystery. But this majestic growth process simply cannot continue forever in the dark. IC 1101 has already completely consumed almost all of the smaller galaxies that were close enough to safely fall into its massive gravitational embrace. Those few that currently remain in the ancient cluster are either entirely too far away or moving much too fast to ever be peacefully captured. This surrounding cluster is actually slowly, inevitably spreading out due to the relentless expansion of the universe, carrying potential future victims farther and farther away from IC 1101's immense gravitational reach. At the exact same time, the larger, infinite universe is fundamentally changing in profound ways that will eventually, inevitably, affect absolutely every single galaxy, including this enormous, fading one. Space itself is quietly expanding in the dark, and it is not just expanding at a steady, peaceful rate. It is actively, mysteriously accelerating in its vast expansion. This mind-bending acceleration is powerfully driven by something scientists poetically call dark energy, a profound, mysterious force that makes up about 68% of the total energy in the entire universe, but whose true, fundamental nature we do not understand at all. Let me gently explain this invisible dark energy a bit more, because it is undeniably one of the absolute most fascinating, puzzling, and humbling discoveries in all of human science, perfectly illustrating the tension between the known and the vast unknown. For most of the 20th century, brilliant astronomers naturally assumed that the overall expansion of the universe was slowly, peacefully slowing down over time. This made perfect intuitive sense to our human minds. Absolutely everything in the vast universe is continuously pulling on everything else through the invisible web of gravity. You would naturally, logically expect all of that combined gravitational attraction to act exactly like a giant cosmic brake, gradually and gently slowing the grand expansion that originally began with the ancient Big Bang. But in the year 1998, two independent, dedicated teams of astronomers made a profoundly shocking discovery in the dark. They were meticulously measuring the expansion rate of the vast universe by carefully observing distant, ancient supernovas, using them as brilliant standard candles to accurately calculate immense cosmic distances. What they surprisingly found was completely, utterly unexpected, gently shattering our previous understanding and inviting a new era of cosmic curiosity. The vast universe was absolutely not slowing down. It was actually speeding up. Distant, ancient galaxies were mysteriously moving away from us vastly faster than closer ones, and the overall rate of expansion was demonstrably accelerating over deep time. This incredible discovery was so completely unexpected that the brilliant astronomers initially thought they had simply made a quiet error in their complex calculations. But as more and more precise data came in from more distant supernovas and from entirely other types of observations, the astonishing result firmly held up. Something invisible, something incredibly powerful, was actively pushing the universe apart in the silence, completely counteracting the gentle pull of gravity and causing space itself to expand at an ever-increasing, staggering rate. Scientists quietly name this profound, mysterious force dark energy. Though the poetic name tells us very little about what it actually is, we now know that dark energy makes up about 68% of all the energy in the entire universe. We know that it acts as a bizarre kind of anti-gravity, forcefully pushing space apart rather than gently pulling it together. We know that its invisible effects become vastly more important over deep time as the universe relentlessly expands. But we do not know exactly what dark energy is truly made of, exactly where it originally comes from, or exactly why it possesses the specific strength that it does. It might be a fundamental, unchangeable property of empty space itself, something called the cosmological constant that the brilliant Albert Einstein once cautiously proposed and then famously called his biggest blunder. It might be a completely new kind of invisible energy field that gracefully pervades the entire universe. It might even be a gentle sign that our deep understanding of gravity itself is somehow incomplete and needs to be completely revised. This beautiful mystery invites us to remain forever curious. What we do know is that dark energy is drastically reshaping the future of the cosmos. As vast space expands faster and faster in the dark, distant objects inevitably recede from us at ever-increasing, unimaginable speeds. There is a strict physical limit to exactly how fast a beam of light can travel, but there is absolutely no limit whatsoever to how incredibly fast space itself can expand. Eventually, over immense eons, celestial objects will be inevitably carried completely away from us by the relentless expansion of space, vastly faster than their ancient light can ever travel toward us. When that melancholic moment eventually happens, they will peacefully vanish behind an invisible cosmic horizon, forever beyond our gentle reach and our human sight. For the majestic IC 1101, this profound reality means that its chaotic days of active growth through galactic cannibalism are strictly numbered in the dark. Eventually, there will simply be absolutely no more galaxies left for it to peacefully consume. It will slowly become entirely isolated, a lonely, fading giant floating peacefully in an ever-emptying universe, quietly watching as one by one the other distant galaxies simply fade away from view into the infinite night. Let me paint a more detailed, contemplative picture of what this incredibly distant future truly looks like. allowing the immense scale to foster a deep sense of inner peace within our own brief lives. Remember that IC 1101 sits safely anchored in the massive Abell 2029 galaxy cluster, completely surrounded by hundreds of other ancient galaxies. These galaxies are still bound tightly together by their mutual gravity, gracefully orbiting around their common center of mass in the dark. For right now, this local gravity is just strong enough to successfully hold the massive cluster together against the relentless expansion of space. But in about 100 billion years, the cosmic expansion will have vastly accelerated to the critical point where galaxies residing safely outside the local supercluster will start to silently disappear over the expanding cosmic horizon. From IC 1101's quiet perspective, the night sky will slowly, inevitably start to empty. One by one, distant glowing galaxy clusters will peacefully fade from view, their ancient light simply no longer able to reach across the rapidly expanding void. The observable universe, which currently contains about 2 trillion majestic galaxies, will slowly shrink and shrink in the silence. Within the Abell 2029 cluster itself, things will be somewhat different for a while longer. The galaxies residing there are close enough and bound tightly enough that they will comfortably stay together even as the much larger universe slowly empties out around them. Over the next several billion quiet years, these remaining galaxies will continue to gently interact, peacefully merge, and slowly evolve in the dark. IC 1101 might still quietly consume a few more straggling victims, growing slightly larger even as the rest of the universe gracefully slips away. The gentle processes that built IC 1101 will continue, drawing the remaining galaxies toward the center to be absorbed into a combined cosmic structure. In the very long run, perhaps in several 100 billion years, all the galaxies in the cluster might merge into a single enormous galaxy, vastly larger than IC 1101 is today. By that distant time, however, the universe beyond the cluster will be completely empty. No light from distant objects will reach the cluster anymore, leaving each island of matter alone with itself as the eons roll by. Have you ever watched a candle burn down to a tiny ember in a dark room and wondered about the ultimate fate of all light in the universe? For IC 1101, the distant future holds a deeply melancholy beauty as the cosmos winds down toward the ultimate heat death. Over the next 100 trillion years, the trillions of ancient stars in IC 1101 will inevitably burn out in the deep night. The massive blue stars went dark long ago, violently exploding as supernovas or silently collapsing into black holes. The gentle, middle-sized stars, much like our warm sun, will slowly puff up into red giants, gracefully shed their outer glowing layers as ethereal planetary nebulas, and quietly fade away as small, cold, white dwarfs. Even the absolute longest-lived stars, the tiny red dwarfs that burn their fuel so slowly they can shine for trillions of years, will eventually exhaust their hydrogen and go dark. In IC 1101, there are untold numbers of these quiet red dwarfs. For trillions of years after the brighter stars have died, the tiny red dwarfs will faithfully continue to burn, providing the absolute last light in an otherwise darkening galaxy. But eventually, even they will fade into the void. Scientists estimate that all star formation in the universe will effectively cease in about 100 trillion years. By that distant time, the gas and dust needed to make new stars will have been completely used up. The era of starlight will be over. One by one, the 100 trillion stars will wink out. Where once there was a blinding blaze of stellar light, there will eventually be nothing but the cold, dark remnants of dead stars drifting through an ever-expanding void. The universe at this unimaginably distant stage will be a profoundly dark, silent place, but it will not be empty. All those quiet stellar remnants, the cooling white dwarfs, dense neutron stars, and silent black holes, will still exist in the dark. They will patiently orbit through the merged, invisible remnant of what was once the magnificent IC 1101. The giant galaxy will simply be a quiet ghost of its former self, populated by the cold corpses of ancient stars. White dwarfs will slowly cool over 1,000,000 billion years until they become black dwarfs, objects that no longer emit any faint light. And the massive black holes, including that enormous 50 billion solar mass monster at the absolute center of IC 1101, will slowly evaporate into the dark through a fascinating quantum process called Hawking radiation. The rate of this silent evaporation is incredibly slow for the supermassive black hole at the center of IC 1101. It would take something like 10 to the 100th power years to fully evaporate, a span of time known as a Google years. It is a span of quiet time so utterly vast that everything we have discussed so far is not even a microscopic rounding error by comparison. But eventually, trillions upon trillions of years from now, even the supermassive black hole at the heart of IC 1101 will have radiated away its absolute last bit of energy and gracefully disappeared from the infinite universe in a final, quiet burst of light. When that final moment eventually happens, there will be absolutely nothing left of the majestic IC 1101. No ancient stars, no silent black holes, no glowing remnants of any kind, just the elementary particles and faint radiation that once proudly made up a cosmic giant, peacefully spreading out through an ever-cooling, darkening universe. The largest galaxy we have ever discovered will have gracefully followed the exact same ultimate path as every other structure in the cosmos, slowly dissolving into the endless night. While this vision of the ultimate future might initially seem deeply bleak, I actually find something strangely, profoundly beautiful and comforting about it. IC 1101 exists right now, in this incredibly brief, glowing moment of cosmic history, when ancient stars still shine brightly and massive galaxies still gracefully glow in the dark. The era of stars is just a passing, beautiful phase, a brief flowering of astonishing complexity, resting peacefully between the chaotic fire of the early universe and the cold emptiness of the far future. We are incredibly lucky to exist right now. Let us gently bring our quiet journey back closer to our earthly home for a moment. Our own beloved Milky Way is not immune to the immense forces that patiently shaped IC 1101. We, too, are actively participating in the grand cosmic dance of galactic interaction and silent merger. Right now, our galaxy is in the ongoing process of gently consuming several smaller, wandering dwarf galaxies in the dark. And in about 4 to 5 billion years, the massive Andromeda galaxy, our nearest large cosmic neighbor, is heading toward us for a magnificent collision. While the slow collision between the Milky Way and Andromeda will destroy their beautiful spiral structures, it will not be a violent collision of individual stars, because the vast space between them is incredibly immense. Over billions of quiet years, the chaotic dance will gracefully settle down, and what was once the Milky Way and Andromeda will blend seamlessly together into a single, large, elliptical galaxy, much like IC 1101. Future astronomers might look back and marvel that their smooth home galaxy was once two beautiful spirals dancing through the void. This profound realization brings me to the absolute most important point of our quiet journey together. When you look up at the infinite night sky, you might naturally feel incredibly small. You might feel deeply insignificant in the face of such staggering vastness. But the very existence of IC1101 actually tells us something profoundly hopeful about our situation. We are fragile human beings living peacefully on a tiny planet, orbiting an ordinary star in an average spiral galaxy. Yet, we have miraculously developed the incredible ability to understand objects so unimaginably far away that their light left before a complex life even existed on Earth. In a vast universe of mindless matter and silent energy, somehow here on our quiet Earth, profound consciousness has beautifully emerged. Consider this deeply beautiful truth. IC1101 is made of the exact same fundamental stuff that we are. The trillions of ancient stars there are magnificent fusion reactors just like our warm sun, patiently burning hydrogen into heavier elements in the dark. The invisible atoms in those distant stars are the exact same kinds of ancient atoms that perfectly make up our own bodies. The beautiful carbon in our muscles, the precious oxygen we breathe, the heavy iron in our blood. As Carl Sagan beautifully reminded us, all these vital elements were forged in the hot hearts of ancient stars. We are absolutely not separate from the vast universe. We are a living part of it. The exact same invisible processes that patiently built IC1101 beautifully built us. The same ancient atoms that shine in distant galaxies shine brightly in our own eyes. We are not merely passive observers of the universe looking in from the outside. We are the universe peacefully observing itself from within. The very atoms in your body were forged in the fiery cores of stars that lived and gently died before our sun was even born. When those ancient stars exploded as colossal supernovas, they gracefully scattered their elemental riches across the dark space. Eventually, some of those ancient atoms found their quiet way into a floating cloud of gas and dust that collapsed to form our solar system. They patiently became the Earth, and after billions of years of gentle evolution, they became you. You are made of ancient star stuff. This is not just lovely poetry, it is rigorous chemistry. In a very real sense, when you quietly contemplate the immense majesty of IC1101, you are ancient star stuff contemplating more star stuff across the infinite silence. The universe is gently looking at itself, trying peacefully to understand exactly what it is and how it beautifully came to be. We are tiny, yes, but in the brief moment of our quiet existence, we can reach out our minds across a billion light years of silence and gently touch the largest galaxy ever discovered. That peaceful reach is our true cosmic glory. Thank you for joining me on this quiet journey through the biggest galaxy ever discovered. If this peaceful video helped you deeply see the universe in a beautiful new way, please consider gently leaving a quiet comment, letting us know what you deeply think about our peaceful place in a cosmos that proudly contains such incredible wonders. And if you want to keep exploring the profound mysteries of the infinite universe with us, do not forget to gently like this video and quietly subscribe to the channel, joining our community of cosmic explorers. Until next time, my friends, keep looking up, keep finding peace in the dark, and keep gently wondering.